All right, let's look at this lemma. In triangle ABC, AE is a point between A and B, and F is a point AC. So A ratio of AE to AB is equal to AF to AC. Then EF is parallel to BC. Right? So that's the statement. Right, so instead of looking at this implication, we're going to look at this contrapositive. So this is a logically equivalent to if EF is not parallel to segment BC, implies that the ratio of AE to AB is not equal to AF to AC. Right, so let's try to show that instead. Right, so I'm gonna just draw a picture to prove this. Right, segment EF is not parallel to BC. Right, so what we're gonna do is we're gonna apply midpoint connector theorem repeatedly. So take the midpoint of AB, so somewhere in here, and AC somewhere in here, and put the midpoint here, midpoint connector, and do a midpoint connector on the top triangle, so midpoint connector, and the bottom trapezoid, we're going to do a midpoint connector, right? And in this process, you can see that at some point, one of the midpoint connector, it's gonna passes through EF, right? So we don't know how many midpoint connector it takes, but it's gonna eventually happen, right? So let's count the number of so these are equally length segment. So you have 1, 2, 3, and so on. So I don't know how many segments it's going to have. So the total, let's say you have n segments, and each one is going to have same length. So I'm going to call this guy A here, A here, A there, right? So total length would be n times A, right? Then here, the particular midpoint connector that passes through EF. So the number here, we're going to say, we don't know how many, so but let's say Ka, right? Right, K is some integer and N is some integer, right? Then you can see that here, each length is exactly the same here, but it might not be the same. It might not be same as A, so I'm going to call it B here. So this is B here, and B here, and B here. So from here to there, we have actually KB, right? Because you're going to have the same number of segments here, and the total length would be NB, right? So if you want to express this ratio, AE over AB, right, in this picture, you can see that the AE is actually shorter than KA. So this is going to be smaller than KA over NA. Because AB is the same thing as NA. So this is same as AB. Right? And so we can cancel A out. Right? And so this is the same thing as K over N. But which is the same thing as KB over NB, multiplying top and bottom by B, right? But you can see that the KB is shorter than AF, right? So this guy is shorter than AF, and the NB is exactly the same as AC, right? So you can see that AE over AB is strictly less than AF over AC. So therefore, we know that AE over AB is not equal to AF over AC, right? So this verifies that, right? But in my picture, it could be the other way around, but the argument is very similar. Say E could be down here and F could be up here, then it might look something like this, right? Then we just have to do a similar argument for that too. But anyway, lemma, so if the ratio of A to AB is equal to AF to AC, that will actually guarantee that segment EF to be parallel to segment BC, right? So that's the lemma, all right? That's it. I hope that this was clear.